Hey, my name's Avery. I look a little crazy because I just got my wisdom teeth out. But in this video, we're going to be looking at Riemann sums and how to use them to approximate area on a graph. Okay, this is take number 2. It randomly deleted my video, so let's try that again. I didn't draw out the function. I did a little in the last time I tried to record this video, but I did write it out up here. It's x cubed minus 5x plus 8, and we're looking at the interval 0 to where n equals 4, and n is our number of subintervals. So the first step in this process is to find your delta x, which is also known as the width of your area formula. So you have b minus a over n, where a and b are points in your intervals up here. 0 would be a, 2 would be b in this case. So 2 minus 0 over 4 equals 1/2, and that is going to be the width of each subinterval. And then I just went through and wrote all of our subintervals out. So 0 to 1/2, 1/2 to 1, 1 to 1.5 or 3 over 2, and then 3 over 2 to 2. And then what you're going to do is take since we're working with the left Riemann sum, take the left endpoint of each of these points. So 0, 1/2, 1, and 3 over 2. So the next part in this process is finding the height value that you would use for your area formula, and you do this by taking each of these left endpoints right here and plugging it into your equation. So you have f of 0, f of 1/2, f of 1, and f of 3 over 2, and I got 8, 5.625, or 45 over 8 if you leave it as a fraction, 4, and then 3.875, or 31 over 8, sorry. And then your final step for this problem is to just take all of these values you found right here, add them up, and then, like I said, multiply by the width that we found earlier, or your delta x. So 8 plus 5.625 plus 4 plus 3.875 is equal to 21.5. And if you multiply that by half, then that leaves you with 10.75 units squared. And that's going to be your approximate area for this equation.